Hello guys, so we were into the JE concepts and our first topic was projectile motion. And in this video, we are going to further move ahead with the same topic of projectile motion. And at first in this video, I'm going to derive the maximum range in case of projectile motion. That is, what will be the maximum range in case of projectile motion. And then after, we will look into how to approach and solve any kind of projectile motion questions. So after this video, you're gonna never find any projectile motion questions tough to solve. And in this video, I'm gonna also cover some basic questions related to this topic of projectile motion, that is school level questions. So let us begin. So at first, as I said, what will be the maximum range of a projectile motion, of any projectile motion? So for that, let us suppose that I'm having a projectile and it is at the earth's surface having an initial velocity u at an angle theta from the horizontal, that is angle of projectile, and this is point O, that is the point of projection. This must be straight like this, and this will take a trajectory something like this. Okay, so just think what will be the variable on which this range depends. First of all, let us again take this as x-axis and this is y-axis. This is actually very important point. Before dealing with any projectile motion question, you must need to choose the coordinate system. And I'm going to discuss about this in this video only. But for now, let us focus completely upon the maximum range of a projectile motion. So my question was what will be the variable on which this maximum range of projectile motion depends? Obviously, first of all, on the magnitude of velocity, that is u. I mean magnitude of initial velocity. That is, if you're gonna throw a projectile with more velocity, and then obviously it will go farther. That is, the range will be more. After that, this angle theta, this angle of projection. If angle of projection will be less, then what do you think? What will happen? And if angle of projection will be more, then what do you think? What will happen? So there are two cases, lesser angle of projection and more angle of projections. And in both the cases, we just can't say directly that in one case range will be more and in the other case range will be less. So we need to see for that. The third variable on which this range depends is the acceleration. Okay. But in this case of ours, we have a constant acceleration of small g in the downward direction, 9.8 meters per second square approximately. Okay, but what if this acceleration is going to increase or decrease? Well, if this acceleration will be more, suppose if g will be more, then obviously the earth will try to attract it forcefully, with more force than the previous 9.8 meters per second square, and that's why the projectile will gonna hit the earth's surface soon, the range will be less. But in case of g lesser than the 9.8 meters per second square, the range will be more, because in that case earth is not going to attract the projectile with that much force as before, that is 9.8 meters per second square. But obviously this is not the whole picture. Obviously I am discussing these cases like g more and g less when our other two factors like theta and u are constant. But if this theta and u changes, then obviously the things will be going to be very different. So we already discussed about this magnitude of initial velocity and acceleration. Now let us discuss about this theta. Okay, so now we have assumed that initial velocity u and acceleration due to gravity small g are supposed to be constant. That is, they are not gonna change. So now the only variable that is gonna change is theta, that is angle of projection. And we are talking about obviously range. And what the range was? So as we derived in the previous video, the range was u square sine of 2 theta upon g, where this is acceleration due to gravity, this was angle of projection, and this was initial velocity. And in this case, we are assuming u and g is constant. So for finding the maximum range or maximum of any variable, we need to take the help of calculus, either for finding the maxima or finding the minima. But in this case, we are going to find the maxima, that is maximum range of a projectile motion. So for that, let us differentiate this x with respect to theta, because x is only a function of theta now, as we are supposing that u and g are constant. So we basically need to differentiate this x with respect to theta to get f dash of theta and then equate this f dash of theta to 0. After equating this f dash theta with 0, we will obviously get some value of theta, okay, that we need to find. After that, we again need to differentiate this like f double dash of theta, and whatever we are gonna find here, we need to put this value of theta over here, and if by putting this value of theta over here, if we are getting this as less than 0, then that will be maxima, and if we are getting this greater than 0, then that will be minima. So this is basically the concept of finding the maxima and minima that I have discussed over here. So let us do that. Well, dx upon d theta from here, that is equal to u square upon g, because this is constant, multiplied by d of theta sine of 2 theta, and this must be equated to 0. So this is basically constant, so let us write this k multiplied by d of theta sine 2 theta will be cos 2 theta multiplied by 2, that must be equal to 0. So from here, cos 2 theta equal to 0. So that is cos 2 theta is equal to 0. Now let us get the values of theta for which cos 2 theta is equal to 0. Now if you look at the graph of cos theta, then it will be something like this, okay, that we know. Here this is pi by 2, this is pi, this is 3 pi upon 2, and this is 2 pi. This is for the cycle 0 to 2 pi of cos theta. This is at 0, the value is 1. That is maximum value of 1 and minimum value is minus of 1. And we are interested in cos 2 theta is equal to 0. Okay. So here we are seeing that at pi by 2 and 3 pi by 2, within the interval of 0 to 2 pi, cos theta is equal to 0. So these are actually the angles, this theta. So let us equate these 2 theta to pi by 2 or 3 pi by 2 for 0 to 2 pi. Then theta will be equal to either pi by 4 or 3 pi upon 4. That will be the value of theta. And what is theta actually? Theta is actually this angle with which the projectile is thrown. So this theta can be either pi by 4 or 3 pi by 4. 3 pi by 4 is actually greater than 90 degrees. This will be actually in this direction somewhat. Like if we are considering the angle as 3 pi upon 4, then the projectile will go like this, not like this. So this will be a different projectile. So that's why we are not going to take this value, okay, because this is a different kind of projectile. It will not going to travel like this, obviously. It will only travel in this direction. So we are only interested towards this theta, pi by 4, that is nothing but 45 degrees. Now as I said that f dash theta is equal to 0 and we get the value of theta as pi upon 4 or 45 degrees. Now let us again differentiate this cos 2 theta. Then the differentiation of cos 2 theta will be what? Minus of sine 2 theta into 2. This is basically f double dash theta. Now when you put 45 degrees over here, then this will be what? Minus of 2, because sine 2 multiplied by 45, that is 90. Sine 90 is 1. So this is 1 and this is 2. So 2 into minus of 1, that is minus of 2, which is negative. That's why this is gonna be the maximum value of range, as I have said. That if f double dash theta is less than 0, then that will be maxima. So at theta is equal to 45 degrees or pi by 4, the range is maximum. Okay, so this is what need to be kept in mind. Like theta is equal to 45 degrees or pi by 4, for which the value of range is maximum in case of projectile. And that's what our question was. Now let us move ahead. Well, here we are gonna see like how to approach and solve any question of projectile motion. And you will be surprised to see that the technique which I'm gonna present here will let you tackle any question related to the projectile motion, no matter how tough it is. Just follow these procedures. So number first procedure is draw the diagram first. You need to draw the diagram first. Just like if somebody is telling that a ball is thrown at an angle of say 60 degrees from the ground with a velocity of this, then first you need to draw that thing here. Like at a velocity say u at an angle theta. So you need to draw like this. Or suppose if somebody is saying that a helicopter is throwing food to somebody standing at a distance of x, something like that, then you need to make a helicopter like this, and the angle at which that food is thrown, either horizontal or at some angle, and the height of the helicopter, then the person standing at a distance x, like the person is here. So you need to have like this distance x, and this height is h, like this. You need to make the diagram to see the picture clearer, otherwise you will get confused. If you'll think that by thinking only I can solve the question of projectile motion, then you might get stuck, because questions can be very good, as I will discuss in the next video. So first thing first is like you need to make a neat and clear diagram of the projectile motion of the question that is being asked. The second thing is you need to choose the axis. Axes are very important in case of projectile motion. Just by choosing the axis, the question will be entirely different, as I'm going to discuss that question too, that how much this axis is important. So you need to choose the axis. Like suppose I have made the diagram here. Now I'm letting this direction as positive x and this direction as positive y. In this case, this is positive x and this is positive y, like that. You need to choose the axis. Okay, the second thing is, and the third thing is you need to bifurcate the variables. Like suppose we have chosen two axes, x-axis and y-axis. So obviously there are variables concerning the x-axis and the y-axis, like the velocity in x direction or the velocity in y direction, acceleration in x direction or acceleration in y direction. Similarly, x is equal to ut plus half at square. But here the values must be of x-axis, like uxt. Similarly here y is equal to uyt plus of half ayt square. So like that, you need to bifurcate the variables of the concerned axis, like x-axis and y-axis. And then after reading the question, you will easily get the picture of what the question is asking and how to approach the question and how to solve the question after approaching that problem. So these three are the very simple step, but you need to follow it very strictly, like drawing the diagram, choosing the axis and bifurcating the variables of x-axis and the y-axis. So in the next two questions that I'm gonna discuss here, I will just follow these three procedures, and you will be surprised to see that how much easy that question will going to be just by following these three procedures. Just look at it very carefully. So the first question is like a particle is projected horizontally with a speed u from the top of a plane inclined at an angle theta. It is not zero, it is basically theta with the horizontal. Here we are talking about plane which is inclined at an angle theta. So let us make the plane. This is a plane and this angle is theta. So a particle is projected horizontally. The particle is projected how? Horizontally, like this. Horizontally means what? That this angle must be 90 degrees with a speed u, like this, from the top of a plane inclined at an angle theta. This angle theta with the horizontal. This is horizontal. How far from the point of projection will the particle strike the plane? Okay. So first of all, I have drawn the diagram. And let us draw the rough trajectory. Like when someone is going to throw a particle like this horizontally from the top of a plane at an angle theta, then it will move something like this. Okay, just suppose that the particle is going to strike here at some point, say P, when thrown from a point, say O, from the top of a plane. So this is the diagram. The first step is over. Like you have made the diagram, you have understood the question. Now the second thing is you need to choose the axis. So here there are two different ways of choosing the axis. First one is the similar one. This is x-axis, positive x, and this is y-axis, like positive y. Second, one can also choose this axis as positive x-axis and this axis as positive y-axis. So as you can see very clearly over here, that even we can choose axis in a different manner, in a different way, and the question will gonna be entirely different. I mean, the approach of the question and the solving procedure of the question is going to be entirely different just by choosing the axis. So this is what the importance of axis is. So this is second, I have chosen the axis, either this one or this one. The third one is just write the variables in that two different directions. So if I'm choosing this axis, like plus x this and plus y this, then in the x direction, let me write the variable. The first variable is like ux is equal to u, the velocity in the x direction. Then acceleration in x direction is going to be 0. See, when I'm choosing this axis, x and y, then acceleration is 0, ax is 0. But if I choose this axis, then you need to divide the acceleration g, which is downward, into two components, here and here. And here in this case, like this plus x and this plus y, there will be acceleration at both the axis, plus x axis also and plus y axis also. In both the directions you will gonna have acceleration, but in this case the acceleration in x direction is 0. Okay, and if the particle strikes at this point P, then let us suppose that this distance, just suppose x, from here this point say A to P, like AP is x suppose, and this is gonna be the range in the x direction, obviously, because this is the origin of that axis, plus x and plus y, and from this origin if a particle goes to this point P, then obviously in the x direction the maximum distance which this particle travel is basically this x. So AP is x and that is the range. And in the y direction, say OA is equal to y, then OA is equal to y is the height where the particle is situated initially from the point P in the y direction, obviously. And if this angle is theta, then this angle will also be theta by the corresponding angle that we all know. So here if I'm going to write the second equation of motion, then it will be something like x is equal to uxt plus of half ax t square, but ax is 0, so this will be u into t only. So this is the time t at which the particle reaches from O to point P. So at time small t the particle is at point P. Now writing this thing in y direction, uy is what? 0. In y direction initially the velocity is 0. Ay is what? That is minus of g, because our positive y in this direction, like away from the earth's surface. So ay is minus of g. So now writing y is equal to uyt plus of half ayt square. That is equal to uy is 0. This is nothing but half minus of g multiplied by t square. And this y is in the negative y direction. So this will be also be negative, minus of y. This minus will become positive. So y is equal to half of gt square. So this is y and this is x. And this question is asking us to calculate OP. Like OP is equal to what? As is clear just by reading the question only, how far from the point of projection will the particle strike the plane? That is OP is equal to what? Now from here you can easily see that this is a right angle triangle. So for finding the OP, that will be nothing but under root of x square plus of y square, that is equal to OP. It's pretty much clear. Another thing is, which is given in the question, is this angle theta, because this x, this y, all these are just variables. We do not know what the x and what the y is. We only know is the initial velocity u in the x direction and the angle theta. So let us use this angle theta. So the plane was something like this theta, and this was u, and this was x, and this was y. So from here we can easily deduce that tan theta is equal to y upon x. That's pretty much clear. And we have already calculated x is equal to ut and y is equal to half gt square. These two things also we know. Okay, so when I just square this, say x square is equal to u square t square, then I can remove this t square because y is equal to half of gt square. So just divide these two equations, then you will get x square upon y is equal to u square upon half into g, like this. And y upon x, we know that it is tan theta. So this will be x multiplied by x upon y, that is equal to 2u square upon g, or x upon y by x we can write it, that is equal to 2u square upon g. So this is nothing but x upon tan theta is equal to 2u square upon g, or I can write it as x is equal to 2u square tan theta upon g. So this is till now that we have found just by using our three principles and nothing else. And these things we already know, like u we know, theta we know, g we know. Now we need to find this OP. We need to find this OP because that was the question. What will be OP? And we now know what the x is, like this x is. So how can you calculate this OP when you know the x? It's very simple. You need to use the trigonometry because this is a right angle triangle. So just by looking at it, I can write over here cos of theta is equal to x upon OP. So OP will be what? X upon cos theta. And we already know this x now. So just have x upon cos theta like this. 2u squared tan theta upon g cos theta. This is what? This is nothing but OP. So this is our answer. We just needed to find this, like the distance from the point of origin where the particle strikes. So this is that distance, 2u squared tan theta upon g cos theta, because cos theta is equal to x upon OP. So OP is equal to x upon cos theta. So this is how simple that question is. But by looking this question at the first sight, you will be somewhat startled, like how to approach this question, how to find that distance. But when you proceed, as I said, drawing the diagram, choosing the axis, and then proceeding in the x and the y direction by writing the variables and the equations of motion, then you will finally get the answer. But you need to move towards the direction of getting the answer. See, first I have written the equation, but why only second equation of motion? Because here we will find the correlation between this x and this y, and ultimately we are going to find this OP, because this is all about the distance. This question is all about the distance. If you want the answer to this question, then you need to deal with the distance in the x direction, in the y direction, so that at last you will reconnect all these things in order to find this OP. That's why I have moved in that direction. So just like this, you need to approach and solve the question. Now moving towards the next question. The next question is like a ball is projected from a point on the floor. Suppose this is the floor with a speed 15 meter per second at an angle of 60 degrees. Suppose like this. This is 60 degrees and this is 15 meters per second. That is the U. With the horizontal, obviously, this 60 degrees. Now the question is asking, will it hit a vertical wall 5 meter away from the point of projection? This is the point of projection. Oh, let us make 5 meter away. Suppose this is 5 meter away. Suppose this is 5 meter. So the question is asking, will it hit a vertical wall 5 meter away from the point of projection and perpendicular to the plane of projection? So this is basically the plane of projection. This. And perpendicular to this, like this, we are having this wall 5 meter away. So we need to check without hitting the floor, perpendicular to the plane of projection and without hitting the floor. Because why this statement is important? Because suppose that the range of this projectile motion will be lesser than 5 meter. Just suppose that the particle is going to strike here for the first time. Then after that it will again bounce back like this, and after that again, and after that again, and ultimately it is going to hit this wall. So this is also going to be the case when this ball is going to hit this wall 5 meter away. That's why it is already clear in the question that the projectile must hit the wall without hitting the floor. So this is already cleared in the question. So you need to hit this wall in the first attempt, like this, or this, or this, or in the limiting case, just this. Just the range is 5 meter in the limiting case. Then also this ball is going to hit this wall. So for this kind of question, it is very clear that we have drawn the diagram. The second thing is plus x axis and this is plus y axis. Okay, in this question the axis is not going to play that much important role as in the case of previous question. But then also you need to follow the procedure. Okay, because we are just the beginners. So at the beginning you need to follow the procedures. So as is clear from the question, we need to find the range in this case. And if that range will be greater than 5 meter, then obviously this ball is going to hit that wall. Like if range is greater than 5 meters in this case, then it is going to hit the wall. But if the range is lesser than 5 meter, then the ball is not going to hit the wall at the first attempt or without hitting the floor. After hitting the floor, it might be the case that this ball will gonna hit the wall, but without hitting the floor, this ball is not gonna hit the wall. That is going to be the second case. So let us find the range at first. The formula for range is u square sine 2 theta upon g. Here u is 15, so 15 square multiplied by sine 2 theta, theta is 60, sine 120 upon g, let us suppose 10. So that is equal to 225 multiplied by sine of 120 is root under 3 upon 2 multiplied by 10, approximately equal to 19.485 meters. So yeah, the range is very far. and the wall is just at 5 meters. So obviously it is going to hit. See, range is what? 19.485, which is greater than 5 meter. So it is going to hit the wall without hitting the floor. And another question is, will the answer differ if the wall is 22 meters away? Well, obviously, if the wall is 22 meters away, then this 19.485 is basically less than 22 meters. Then this ball is not going to hit the wall without hitting the floor. So that is the answer to the next question. No, and for this, yes. Now let us move towards the next question. Well, this is basically an objective type question. In a projectile motion, the velocity is always perpendicular to the acceleration, is never perpendicular to the acceleration. It's perpendicular to the acceleration for 1 instant only. It's perpendicular to the acceleration for 2 instants. It's a very important question. It's a very useful question. It's a very deep dive question. So let us make a projectile like this. This is u, suppose, at an angle theta. This will move just like this, and it will strike again at here, say point P, and this is point O. Again, let us make the axis. This is plus x and this is plus y. So here at this point, from where the projectile is thrown, the velocity is at an angle theta with the horizontal, and acceleration at this point is this small g, perpendicular to the horizontal, and this acceleration is constant. At each and every point the acceleration will be just like this, perpendicular to the horizontal, like this, 90 degrees. But the velocity at each and every point of this projectile is going to change, like this, like this, like this, like this, like this, like this. Okay, but if acceleration is perpendicular to the horizontal, at each and every point of travel of this projectile, the acceleration is just going to be the same, that is small g, and perpendicular to the horizontal. And the question is asking velocity of the projectile at what point will be perpendicular to the acceleration. So the answer is same. When the velocity is horizontal, then only that will be perpendicular to the acceleration. And in the whole trajectory of this projectile, there is only one point at which velocity is going to be horizontal, and that is at the highest point, at this point. So only at this point, this velocity is basically perpendicular to the acceleration. So the answer is C. Like in a projectile motion, the velocity is perpendicular to the acceleration for 1 instant only. So these are the 3 questions which made you a little bit clear on the projectile motion side, like how to approach that question and how to solve that question. In the next video, we are going to look at some more complex questions related to the projectile motion, which is going to build your concept even more just by following those 3 procedures, which is going to build your concept even more. So let us wait for the next video, guys. Until then, thank you.